Good day, I am Okwanachi Melchizedek. With me are
Florence Jongia.
Sylvia.
we are in SS2 Hope Academy Schools, Jos. Our experiment is titled Determination of Heat of Combustion of Ethanol. The heat of combustion, also known as enthalpy, is the heat evolved when 1 mole of a substance is completely burned in oxygen. It is determined using a calorimeter. A unit of measurement of heat is calorie, and 1 calorie of heat is the amount of heat needed to raise the temperature of 1 gram of water by 1 Kelvin. Hence, the work done in raising the temperature of 1 gram of water by 1 Kelvin is termed specific heat capacity of water, and the value is 4.18 joules per gram per Kelvin. Ethanol burns completely in oxygen to give carbon dioxide and water. In the experiment, the heat of combustion of ethanol will be determined from the amount of ethanol used to raise the temperature of 100 grams of distilled water. Now, Sylvia will show us the materials needed for the experiment.
Thank you. The material needed for this experiment are calorimeter, thermometer, weighing balance, ethanol lamp, lighter, beaker, distilled water, retort stand, and ethanol. Now I'll be handing over to Florence to continue from here.
Thank you, Sylvia.
Before starting the experiment, it is good to describe this calorimeter. This calorimeter consists of a small container placed inside a bigger container. The smaller container is larger from the bigger one to prevent heat loss, and inside the smaller container is this stirrer and a thermometer. It is also good to describe the ethanol lamp. It contains the lamp wick inserted through the cork of the bottle and dipped into the ethanol in the bottle. Now Corey will continue from here.
Thank you, Florence.
Procedure Step 1. Weigh 100 grams of water in the calorimeter. After clamping the calorimeter, now insert the thermometer. Note the initial temperature of the water. In this case, it is 29 degrees Celsius. The next step is to weigh the ethanol lamp.
The weight here is 125.59 grams.
Place the ethanol lamp underneath the calorimeter. And ignite it. Use it to raise the temperature of the water by 31 degrees centigrade. That is to a temperature of 60 degrees Celsius. This ethanol lamp is supplying heat to the calorimeter, and the temperature of the water is increasing as the ethanol is burning. The thermometer reading is of 55. approaching 60. The temperature of water has risen to 60 degrees Celsius. Now the fire will be put off. Now we will take the final mass of the ethanol and lamp. The mass is 125.11 grams.
The final temperature is equal to 660 degrees Celsius, equivalent to 333 Kelvin, and the initial temperature is 29 degrees Celsius, that is equivalent to 302 Kelvin. Difference in temperature is 333 Kelvin minus 302 Kelvin, which is equal to 31 Kelvin. Now, initial mass of ethanol plus lamp is equal to 125.59 grams, and the final mass of ethanol plus lamp is 125.11 grams. Therefore, the difference in mass is equal to 0.48 grams. Heat capacity is given by mc delta theta, where m is the mass of water, which is 100 grams, c is the specific heat capacity of water, which is 4.2 joule per gram per Kelvin. Delta theta is the change in temperature, which is 30 Kelvin. Therefore, the heat capacity H is equal to mc delta theta and is 100 times 4.2 times 31, and we have 13,020 joules. This is the heat generated by the burnt ethanol to raise the temperature of the water by 31 Kelvin. To calculate the heat of combustion of ethanol, first find the mole of the ethanol bond. That is, mole equals to mass over molar mass. Then the molar mass of ethanol is 46 grams per mole. Mass of ethanol, therefore mass of ethanol bond is 0.48 grams. Mole is equal to 0.48 over 46, and we have 0.0104 mole. If the heat evolved for the combustion of 0.0104 mole of ethanol is 13,020 joules, then the heat of combustion of 1 mole of ethanol will be 13,020 over 0.0104, which is equals to 1,251,923 joules, which is approximately to be 1,251 kilojoules. Thank you.